Hello, students. We are going to start chapter 13, Motion and Time. In this chapter, we are going to learn about slow or fast motion, speed, importance of measurement of time, how to measure speed, different types of distance and time graph. Suppose you're standing near the open window of your room. What do you observe? You can see vehicles, cars, buses, cycles. All are moving. No one seems to be at rest. All are in motion. So, what do you understand by the word motion? Motion. The object which changes their position with respect to the object at rest are called in the state of motion. Now, if you are asked to tell whether the trees or building are at rest or motion, you can give the answer. A body relative to one object may be at rest, whereas relative to the other object it may be in motion. So what is motion? The object which changes their position with respect to the object at rest is called motion. So we can have slow motion or fast motion. Object may travel fast or slow. If the object covers larger distance in a fixed interval of time than some other objects, then it is called as faster and the other object is called as slower. Measurement of time. How can we measure the time? How is one aware of the time? Certainly you answered that we will be in favor of a watch or a clock. But do you know in the olden days people did never use the watch or clock? So in ancient times, when there was no time measuring devices such as clock, people relied on the natural phenomena to keep the track of the time. That is day. What is day? The time interval between one sunrise to the next was considered as day. Then night. The time interval between one sunset to the next immediate sunrise was considered as night. Month. The time interval between one new moon and the next was considered as a month. Year. The time taken by the earth to complete one revolution around the sun was considered as year. Next, evolution of clock. How the discovery of clock has taken place. The first clock which was discovered was sundial. A sundial has a circular plate with triangular metallic plate called gnomon. This gnomon was fixed at its center, pointed at an angle. The device is placed in the open sunlight in such a way that gnomon points in the north-south direction. The major drawback of using the sundial is that the device cannot be used during the night time and the cloudy days. So, this is sundial. It is a circular plate on which a triangular metallic plate is present at the center. This is called as gnomon. This sundial is placed in the sunlight. It is placed in such a way that this gnomon points towards the north-south direction. The major drawback of this sundial is this sundial does not work in the cloudy days or in the night time. So in the absence of the sun, this sundial will not work. So next discovery was sand clock. The word sand clock means the sand is present in between the two glasses. A sand clock is known as hourglasses. It measures the passage of few minutes of an hour of time. It has two vertical glass bulbs, allowing the regulated sand from top to bottom. Once the top bulb is emptied, it can be inverted to begin the time again. So this is sand clock. If this sand is emptied from the top, again it is inverted, and it is used for measuring few minutes or 1 hour. Next, pendulum clock. A pendulum clock is based on pendulum. This is pendulum. This is metallic bob. It is metallic bob is tied to the thread, and this thread is hanged over a rigid support. A pendulum clock is based on pendulum. A simple pendulum has a metallic bob suspended from the rigid stand by a thread. The rest position of the bob is called as the mean position or equilibrium position. When displayed, the bob of the pendulum undergoes to and fro motion. Then the pendulum is said to have completed one oscillation when the bob moves from one extreme position to the other and back. This is mean position or equilibrium position. This bob is taken to the one side. This is an extreme position. This is one extreme position. So when the bob is taken to the extreme position, it is left. The bob goes to the other position and then again to come back to the same position. So we see one oscillation has been completed. This metallic bob has to go to the other extreme end and then again back to the same. Then we see that one oscillation has been completed. Next, time period. The time taken by the pendulum to complete one oscillation is called as time period. The time taken of a simple pendulum varies with the length of the thread but does not vary with the mass of the bob. Okay, the time period of the simple pendulum changes with the length of the thread, but it does not depends upon the mass of the bob or with the distance of the bob from the mean position. Next, periodic motion. The oscillation of simple pendulum are periodic. That is, they repeat themselves after the fixed intervals. Such motions are called as periodic motion. The oscillation of the simple pendulum are periodic, means it repeats after regular intervals of time. Then that kind of motions are called as periodic motions. Next, quartz clocks. With the invention of the quartz crystal in 1921, in 1927, quartz clocks were discovered. The timekeeping accuracy was highly improved in the quartz clock, replacing the pendulum clocks. Next, atomic clocks. Atomic clocks, they give the accurate time. So atomic clock is a device that uses electronic transition frequency in the ultraviolet region of electromagnetic spectrum of the atom as standard. So we have electromagnetic spectrum. In that spectrum we have different regions like ultraviolet region, infrared region, visible region. So atomic clocks are uses the frequency in the ultraviolet region. So these atomic clocks give the most accurate time. They are the accurate time keeping devices. Next, speed. Speed is, what is speed? Speed, we can define the distance covered by the body in the unit time is called as speed. It is denoted by speed is denoted by kilometers per hour, but the SI unit of speed is meters per second. Every vehicle has a speedometer and an odometer. The speedometer indicates the instantaneous speed of the vehicle, while the odometer displays the distance traveled. So, speedometer tells about the speed of the vehicle, odometer tells about the distance traveled. Then, how to calculate average speed? Average speed is defined as the total distance traveled in total time. So, average speed formula is total distance traveled by total time. Next, uniform and non-uniform speed. Uniform speed. If an object covers equal distance in equal intervals of time, then the object is to be moving in the uniform speed or constant speed. For example, if an object covers 5 kilometers in 2 minutes, next 5 kilometers in next 2 minutes, next 5 kilometer in next 2 minutes, so it is covering equal distance in equal intervals of time, we say that the object is moving with the uniform speed. If an object covers unequal distance in equal intervals of time, if an object covers unequal distance in equal intervals of time or equal distance in unequal intervals of time, then we say that the object is moving in the non-uniform speed or varying speed. Suppose if an object covers 5 kilometer in 2 minutes, 2 kilometer in next 2 minutes, 3 kilometer in next 2 minutes, see, distance is different but the time is same. So this is non-uniform speed. Similarly, we have uniform motion, non-uniform motion. If a body is said to have uniform motion when it travels equal distance in equal intervals of time, then non-uniform, if a body is said to have the non-uniform motion when it travels unequal distance in equal intervals of time. See, as we have done in the speed, in the same way, uniform and non-uniform motion, a body is said to have the uniform motion when it travels equal distance in equal intervals of time, and non-uniform motion is unequal distance in equal intervals of time, then we say it is a non-uniform motion. Next, distance time graph. We draw a graph between distance and time, then we say it is a distance time graph. If the object is stationary with respect to the time, suppose if you have a car or a Activa in your home, the object is at rest, it is not moving but the time is increasing, but the object is at rest, then we get a horizontal line on the distance time graph. Now we are going to plot a distance time graph, distance on y axis and on x axis we take the time, the object is at rest, then we get a straight line, a horizontal line. See, distance is constant, the time is increasing. Next, if an object is moving with the steady speed, means if it covers equal distance with equal intervals of time, that is uniform speed, then you get the time increases to the right and the distance also increases steadily. The distance time graph of uniform motion gives a straight line, you get a straight line. Next, if the object is moving with the varying speed, it covers unequal distance in equal intervals of time, means the distance is unequal but the time is equal, then you get a curve. So for non-uniform motion, the distance time graph is a curve. Till here your chapter has been completed. Thank you.